Hello, welcome everyone, welcome back to my channel. Today we are doing factorization. In factorization, there are few things that you have to keep in mind, but most important thing is that you have to find the factors. Well, rather than giving some examples, I would say if we'll do the sheets directly, then it would be much easier for you to understand how to factorize all the type of questions. See this one. The first one says factorize the following, which is x squared plus 4x. As I told you, your first instinct is to make factors, and that can be done by taking out something as common. If something has a quadratic, that means if it's in this format. This means the highest degree of x is 2. How to factorize? If your quadratic has all the constants here, that means x squared is present, x is present, and the constant number is present, then it would be done by a particular method which is called splitting the middle term, where we have to think of two numbers. Many of you are aware of this method where you have to find two numbers. Their sum should be equals to b and the product should be equals to a times c, and that we will be discussing later. Then there are the type of quadratics when c is absent. This is the first type, where your c is equals to 0. It's not present at all. You have to take out something out as common. You don't have to go for the splitting middle term, which makes no sense in this case. So it's just simply you have to take out as common. The first question is an example of that quadratic which has c 0. That means out of x squared and 4x, I can take out x as common and remaining is x plus 4. Whatever you are taking out as common, the same number or the term you have to divide with every term. So you have taken out x out as common. So divide x with x squared and 4x by x. You'll get this answer. This is your final factors. X is one factor, whereas x plus 4 is another factor. Always keep that in mind whenever you are factorizing. The first instinct is take out something as common. If you can find, even from quadratics or cubics, if you can take out even a constant out as common or a variable as a common, you have to take out. So what's your first instinct? You can note it down while factorizing. Try to find if you can find something or if you can take out something as common or not. Moving on to the next one, it's 2x squared minus 8x. Again, it's an example of that quadratic which has c0. So in this case, it's simple. We just have to take out as common. So 2x is common in this case. So 2x squared over 2x is x. And 8 minus 8x over 2x is minus 4. This is your final answer. Moving on to the part C, which is also an example of a quadratic whose c is 0. So I'm taking out 3c as common. Remaining is 3c minus 2. Let's see part D. 2xy squared minus 9xy. So as I told you, your first instinct is to take out something as common if you can. So I can clearly take out 3xy as common. So remaining here is 4y and here it's just 3. You can't factorize it further, so that's your final answer. For the next one also, the variables are having a lot of powers. So obviously my first instinct is to take out as common. So I'm taking out x to the power of 3, or I can take minus x to the power of 3 out as common. Remaining here would be 16 and here it would be plus 17x squared y cubed. Your second thing is, if you have taken out something out as common, after that you have to see the factors. Can you factorize them further? Can you split them further? In this case, we cannot factorize it further, so leaving it like this. Moving on to the next one, following the same instinct, that means taking out something as common. I can clearly see 12 is common. X to the power of 4 is common. The smallest power you can take out as common. So out of x to the power of 4 and x to the power of 5, the smaller one is x to the power of 4, and you can take out as common. Similarly, and y to the power of 5 and y to the power of 3, y to the power of 3 is smaller. I can take out it as common. And whatever you have taken out as common, divide that term with every term to get the answer inside the bracket. So 12x to the power of 4 y5 over 12x to the power of 4 y cubed will give you y squared. So y squared would be remaining here, and here it would be 2x. Now let's see, can I factorize y squared minus 2x further? Well, I can't, so just leave it like that. So remember what I did after taking out 12x to the power of 4 and y cubed as common. Like here, I have divided each term. That means 12x 4y5 divided by 12x 4y cubed minus 24x 5y cubed over 12x to the power of 4y cubed. And that's why after cancelling out, I got y squared minus 2x inside the bracket. Moving on to the next one, well, it's a trigonometric function. Sine x squared minus sine x. So sine x squared, that means it's nothing. It's sine x whole squared minus sine x. Obviously, I can take out sine x as common. The smaller power I can take out as common. So sine x as common, remaining would be sine x minus 1. So that's the final answer. Moving on to the next one. 4 to the power of n and 16 to the power of n. If you have done the indices before, you know we have to always, whenever such type of questions are there, we have to try to make the base same. That's our main aim. And same, our base is 4. How can I make it 4 as well? 4 squared is 16. So this is 4 to the power n plus 16 can be written as 4 squared whole to the power of n. And there's a rule of indices. If you are not aware of this rule, I'm writing it down. It's a to the power of m whole to the power of n is a to the power of m into n. That means if 2 to the power of 3 whole to the power of 2 is given, then answer would be 2 to the power of 3 into 2, that is 2 to the power of 6. So if there is a power over another power, you have to multiply these powers. So 4 to the power of 2 whole to the power of n will give you 4 to the power of n plus 4 to the power of 2n. Obviously, out of n and 2n, the smaller number, the smaller power is n. So that I can take out as common. So 4 to the power of n can be taken out as common. Remaining is 4 to the power of n over 4 to the power of n. Whatever you are taking out as common, you have to divide it. Plus 4 to the power of 2n over 4 to the power of n. So this would be 4 to the power of n inside the bracket 4 to the power of n over 4 to the power n is 1 plus, again here we have to apply the rule of indices, which says a to the power of n over a to the power of n. If you are dividing two indices having the same base number but a different power, that means 2 to the power of 3 over 2 to the power of 2. The powers are different, but the base number 2 is same. In that case, you have to write the base number and you need to subtract the power. And here we will be doing the same. That means the base number 4 is same, you have to subtract the powers. So final answer is 4 to the power of n times 1 plus 4 to the power of n. That's your final answer. Moving on to the next one, it's factorizing the following quadratic terms. These are the example of those quadratics where all the coefficients are present, a, b, and c. And this can be factorized by splitting the middle term. Well, here we have to think, if I compare it with ax squared plus bx plus c, the standard quadratic equation, I got a as 1, b as negative 14, and c as 48. Think of two numbers, their sum should be equals to b, and the product should be equals to a times c. It's always, doesn't matter what type of quadratic is there. If you are doing the factorization, you have to find the sum of two numbers. Think of two numbers, their sum should be equals to b and product should be equals to a times c. That means in this case, sum should be equals to negative 14 and product should be equals to 48, because 1 times c or 1 times 48 is 48. Well, if you find it difficult to find two numbers, always start with the product. What product is? Product is 48. Always start with this one and prime factorize it. Prime factorize, that means using the factor tree method, you have to find all the factors. When you multiply them all together, you'll get 48. So by factor tree method, I got 48 as 2 times 2 times 2 times 3 and 2, 2. This is how you can prime factorize. The next thing is you just have to mix and match. That means, let's say these two make one number 4 and these all make another number, which is 12. 12 into 4 is 48, but 12 plus 4 or 12 minus 4 will not give me 14. Well, one more thing. If sum is negative and product is positive, clearly both numbers are negative. That's the only possible case. That means if I'm thinking of 4 and 12, it should be minus 4 and minus 12. Both has to be negative. And I can clearly see that this is not the correct number. So go and mix matching with other. Let me make this one. This makes 8. This makes 6. Make it negative as both numbers are negative. Minus 8 into minus 6 is 42. 48, that's correct. And minus 8 minus 6 is minus 14. That means yes, minus 8 and minus 6 are our number. In this case, you can opt a direct shortcut. If a is 1, whatever number you are selecting. You have selected two numbers, minus 8 and minus 6. You can just directly write it x minus 8 and x minus 6. This will be your factor. That's it. But this is only in the case when a is 1. When a is not 1, don't ever apply this short trick. You have to go by the conventional split the middle term. Moving on to the next one. Sum should be equals to b, which is negative 3, and product should be equals to a times c, which is minus 28. Now, first of all, if there is a negative or positive sign, you have to decide that numbers are going to be positive or negative, or one positive, one negative. Product is negative. That means one number has to be negative, because product, if both numbers are negative, product is going to be positive. Both are positive, product is positive. That means clearly I get to know that one number has to be negative. If sum is negative, it's obvious that the bigger number is a negative number, because minus 8 plus 3 is minus 5. But 8 minus 3 is plus 5. So whatever is your bigger number, that sign we use. So I get to know in those two numbers, one has to be negative, one has to be positive. The bigger number has to be negative. So, and the next is finding the two numbers, and that we can do by splitting the 28. Find the prime factors of 28. This can be done 7 into 2 into 2. By mix and matching, 14 and 2, bigger number has to be negative. No, it's not giving you minus 3. 4 and 7, bigger number has to be negative. Minus 7 plus 4 is negative 3. That means our two numbers are negative 7 and 4. So here it would be, since a is 1, I'm directly writing x minus 7 times x plus 4. Here the sum should be negative 37 and product is 70. That means both numbers has to be negative. So two numbers are 35, negative 35 and negative 2. How I found? Same. You have to prime factorize and then mix and match. You'll get the answer. So x minus 35 times x minus 2. Moving on to the next one. Exactly. If they both are positive, clearly your two numbers are also positive. Product should be 245 and sum should be 42. You have to prime factorize 245 and then by mix and match, doing that, you will get the two numbers. The two numbers are 35 and 7. So directly I can write x plus 35 and x plus 7. Moving on to the next one. Now here a is not equals to 1. On comparing with the standard equation, I'll got a as 2, b as 41 and c as 105. That means we have to do the conventional split the middle term. Sum should be 41 and product should be a times c, 105 times 2. Don't always go for just c. Product is always a times c. So 105 into 2. This will give you 210. So the two numbers are 6 and 35. Now pay attention. This is a splitting the middle term. That means I need to split this middle term into 6 and 35. So in place of 41x, I'll write 35x and 6x. So plus 6x plus 35x plus 105. Now many of you will ask, what if I'll write 35 here and 6 here? Also, you'll get the same answer. So it doesn't matter in which order you are writing. You just need to split them. Taking out 2, you just have to make the pairs. After splitting the middle part, you have to make the pairs. So from the first pair, I can take out 2x as common. Remaining would be x plus 3. From the second one, I can take out 35 as common. Remaining would be x plus 3. Now you have two terms. This is your first term. This is your second term. Clearly, I can take out x plus 3 out as common. So x plus 3 as common and remaining would be 2x plus 35. This is your final answer. Moving on to the next one, which is exactly the same where a is not equals to 1, instead it's 12. So we have to find the sum which is equals to negative 34 and product should be equals to minus 90 times 12. This is a bit difficult, but you will get two numbers as minus 54 and 20. These are two numbers. Well, I'll split this middle term and I'll get 12x squared minus 54x plus 20 minus 90x. Same, making the pairs. I can take out 6 as common. 6x. Remaining 2x minus 9. And here I can take out 10 as common. Remaining would be 2x minus 9. Now out of these 2x minus 9 is common and remaining is 6x plus 10. You can further take out 2 as common from here as well. So 2, remaining would be 3x plus 5 times 2x minus 9. Moving on to the question number 3. See, this one, 2x plus 1 whole squared plus 5 times 2x plus 1 plus 6. Don't try to expand it and then try to factorize. It would be much difficult in that case. Instead, you can convert it into a quadratic. Suppose if I'll write 2x plus 1 as y. If I do that, this one can be written as y squared. This is 5y and 6. This is pure quadratic and it's very simple to factorize. Two numbers, sum is 5, product is 6, two numbers are 3 and 2. So your factors are y plus 3 and y plus 2. What was our y? 2x plus 1. So in place of y, I'm just writing 2x plus 1. So 2x plus 1 plus 3 times 2x plus 1 plus 2. Final answer is 2x plus 4 times 2x plus 3. Or you can take out 2 as common from here as well, or this one's correct. In this way, you can easily factorize rather than expanding every term first and then try to factorize. Here, as I told you, your first instinct is to take out something as common. There are only two terms given. It's not in a form of quadratic, so you cannot convert it like this. It's not an apparent quadratic. It's just you can take out x minus 1 as common. So taking out x minus 1 as common, remaining was x plus 5 plus 2x plus 3. So x minus 1 times 3x plus 8. This is your final answer. Moving on to the next one. Clearly, if I take out negative as common, remaining is 2x plus 1, x plus 1 minus 2x plus 1 times x plus 2. I can take out minus 2x plus 1 as common. So minus 2x plus 1 out as common. Remaining is x plus 1 and plus x plus 2. As I told you, whatever you are taking out as common, you have to divide that number with every term. So since we have taken out negative 2x plus 1 out as common, on dividing the first term, I got x plus 1. And on second term, I got x plus 2. Final answer is negative 2x plus 1 times 2x plus 3. This is your final answer. Now moving on to the very last question. Clearly, there are so many variables and numbers you can see. So you have to take out something as common which you can. And here in this case, c squared I can take out as common. X squared minus 25y squared is remaining. Now this is the third type of quadratic. We have seen ax squared plus bx plus c. When c is not present, we have seen how to factorize. When a, b, c all are present, how to factorize. This is the case when b is not present. Don't say what happens when a is not present. When a is not present, then it will no more be a quadratic. So this is the third case where b is not present, and there is a short trick for it directly. Because there is a negative sign in between. Important thing is it should be in the format of a squared minus b squared. Your x squared is present. This can be a number as well, but they both should be separated by the negative sign. In that case, suppose it's x squared minus 1. Here b is not present, but both has to be a square number and has to be separated by negative sign. It can also work for x squared minus y squared if two variables are there. So two square numbers separated by a negative sign. This has a direct this also be done by splitting the middle term because it's a quadratic. But instead we'll use a direct formula, which is the root of x squared is x and root of y squared is y. And same, I'll write x minus y. That would be the final answer. Similarly, if it's x squared minus 1, this is actually both are squares separated by negative sign. So root of x squared is x, root of 1 is 1. So x minus 1 and x plus 1 will give you answer. So I'm gonna apply the same here. So they both are square numbers. How? X squared minus 5y whole squared. And they are separated by negative sign. So root of x squared is x and root of 5y squared is 5y. So x minus 5y times x plus 5y c squared. This is how you can factorize. So rather than giving a separate video, making a separate video on factorization, I thought it would be better if I'll incorporate with the worksheet directly so that you can see the examples. This worksheet and a written format rather than handwritten, it's a proper printed form, is available on exacademy.com on the website. And if you want personalized classes, the GCSE classes for all subjects are at just £6 per hour. All you need to do is just drop us an email at exactacademy@gmail.com. Also, if you need mock papers or the worksheets, well, most of the worksheets you can find there for free for every topic. And if you are looking for custom or the paid worksheets or one-on-one or group classes, live online classes, even classes from year 1 to year 13 for any subject, just drop us an email at exactacademy@gmail.com. So that's it for today. Thank you. Have a great day.